Albert Einstein, a name synonymous with genius, emerged from humble beginnings. Born in Ulm, Germany in 1879, his early life held no obvious signs of the remarkable path he would forge. The small town of Ulm, nestled on the banks of the Danube River, was a quiet place, far removed from the bustling centers of intellectual activity. His family was not wealthy, and his upbringing was modest. His father, Hermann Einstein, was a salesman and engineer, while his mother, Pauline, took care of the household. They lived in a simple home reflecting the economic challenges of the time. Yet, even as a child, Einstein possessed an unquenchable thirst for knowledge and a deep fascination with the mysteries of the universe. He was a curious and inquisitive child, often lost in thought and wonder. His parents encouraged his curiosity, providing him with books and educational toys. One often told story recounts Einstein's first encounter with a compass. This seemingly ordinary event would leave an indelible mark on his young mind. At the age of 5, the young boy became mesmerized by the invisible force guiding the needle. He couldn't understand how something unseen could have such a powerful effect. This simple object sparked a lifelong curiosity about the hidden forces that govern the natural world. It was a moment of revelation, igniting a passion for science and discovery that would never fade. Little did he know that this curiosity would lead him to revolutionize our understanding of space, time, and gravity. From these humble beginnings, Einstein would go on to develop theories that changed the course of physics and our comprehension of the universe. His journey from a curious child in a modest home to one of the greatest minds in history is a testament to the power of curiosity and the pursuit of knowledge. Einstein's early education was not without its challenges. He clashed with the rigid rote learning methods of the traditional German school system. His independent mind and inquisitive nature were often stifled, leading to conflicts with teachers who prioritized memorization over critical thinking. Despite these obstacles, Einstein's passion for learning could not be suppressed. He excelled in mathematics and physics, teaching himself advanced concepts beyond the scope of his formal education. His natural curiosity led him to explore scientific ideas independently, laying the foundation for his future breakthroughs. Einstein's graduation from the Swiss Polytechnic in 1900 did not mark the end of his challenges. In fact, it was just the beginning of a journey filled with obstacles and triumphs. Despite his exceptional academic performance, Einstein faced significant hurdles in securing a position in academia. Unable to secure a teaching position, he took a job at the Swiss Patent Office in Bern. This job, though seemingly mundane and unrelated to his true passion, became a pivotal chapter in his life. While seemingly mundane, this position provided Einstein with a steady income and, more importantly, ample time to ponder the mysteries of the universe. The routine nature of his work allowed his mind to wander freely, exploring the depths of theoretical physics. It was during these years at the patent office that Einstein's genius truly flourished. The environment, free from the pressures and expectations of academia, allowed him to think outside the box and challenge conventional wisdom. Freed from the constraints of academia, his mind soared. He was able to delve deeply into his thoughts, often losing himself in contemplation and reflection. This period of intellectual freedom was crucial for his development as a scientist. He spent his evenings and weekends immersed in scientific thought experiments, challenging established theories and formulating his own revolutionary ideas. His home study became a sanctuary where he could explore his theories without interruption. In 1905, Einstein's intellectual labor culminated in what is now known as his Annus Mirabilis, his miracle year. This year was a turning point not just for Einstein, but for the entire field of physics. In a burst of creativity, he published 4 groundbreaking papers that would forever change the course of physics. These papers were not just incremental advancements, they were revolutionary ideas that challenged the very foundations of scientific thought. These papers introduced his theory of special relativity, a concept that fundamentally altered our understanding of space and time. This theory proposed that the laws of physics are the same for all non-accelerating observers, and that the speed of light is constant regardless of the motion of the light source. He also explored the photoelectric effect, which would later earn him the Nobel Prize in Physics. This work demonstrated that light could be understood as quanta of energy, or photons, which was a groundbreaking concept at the time. Additionally, he provided evidence for the existence of atoms, further solidifying the atomic theory of matter. His work in this area helped to bridge the gap between theoretical physics and experimental evidence, providing a more comprehensive understanding of the natural world. Einstein's theory of special relativity, published in 1905, challenged the very foundations of Newtonian physics. This groundbreaking work was a radical departure from the established norms of the time, shaking the scientific community to its core. For centuries, scientists had adhered to Isaac Newton's laws of motion and gravity, which described a universe where time and space were absolute and unchanging. Newton's laws provided a framework that explained the motion of objects and the forces acting upon them, forming the bedrock of classical mechanics. Einstein's theory shattered this paradigm. It introduced a new way of thinking about the universe, one that was more complex and nuanced. The implications of his work were far-reaching, affecting not just physics but our entire understanding of reality. Special relativity introduced the concept that time and space are not absolute but are relative to the observer's motion. This means that two observers moving at different velocities will experience time and space differently. This was a revolutionary idea that required a complete rethinking of the concepts of time and space. One of the most famous consequences of this theory is the idea that time slows down as an object approaches the speed of light. This phenomenon, known as time dilation, has been confirmed through numerous experiments, including those involving high-speed particles and precise atomic clocks. This concept, while counterintuitive, has been experimentally verified countless times. Scientists have observed time dilation in particle accelerators, where particles moving at speeds close to the speed of light experience time more slowly than stationary particles. Einstein's theory also established the famous equation E equals mc squared, which demonstrates the equivalence of energy and mass. This equation shows that a small amount of mass can be converted into a large amount of energy, a principle that underlies many modern technologies. This equation has had profound implications for our understanding of the universe, from the energy released in nuclear reactions to the formation of stars. It explains how stars generate energy and how nuclear power plants produce electricity. In 1915, Einstein published his theory of general relativity, which extended special relativity to include gravity. This new theory provided a more comprehensive understanding of the universe, incorporating the effects of gravity into the framework of relativity. General relativity describes gravity not as a force, but as a curvature of space-time caused by the presence of mass and energy. This means that massive objects like stars and planets warp the fabric of space-time, creating the effect we perceive as gravity. This revolutionary theory has had a profound impact on our understanding of the universe, from the behavior of black holes to the expansion of the cosmos. General relativity has provided the foundation for much of modern astrophysics, helping us to understand phenomena such as the bending of light around massive objects and the accelerating expansion of the universe. One of the most exciting recent confirmations of general relativity is the detection of gravitational waves. These ripples in space-time, caused by violent cosmic events like colliding black holes, were first predicted by Einstein and have now been observed by advanced observatories like LIGO. The principles of relativity also play a crucial role in everyday technology. For example, the Global Positioning System, or GPS, relies on precise time measurements that account for the effects of both special and general relativity to provide accurate location data. As we continue to explore the universe, the theories of relativity remain essential tools for scientists. They help us navigate the complexities of space travel, understand the behavior of distant celestial objects, and unlock the mysteries of the cosmos. Einstein's work on relativity has left an indelible mark on science. His theories continue to inspire new generations of physicists and drive forward our quest to understand the fundamental nature of reality. The journey of discovery that began with Einstein's insights is far from over, and the mysteries of relativity continue to unfold.